We have the great honor of having the Worldwide Services CTO for Microsoft, Norm Judah, taking the floor to talk to us a little bit about how you get into a digital enterprise beyond just pure IT. So Norm, over to you.
Thank you. Thanks. Good morning. What I want to do is spend a little bit of time talking about some things that we've learned from building applications, building real AI applications and the consequence of that, with part of it being a major theme about the ethics of AI, the pragmatics of AI, what it means to actually build an AI strategy, and some of the elements that come out of that. And so the way we think about AI is really about responsible, trusted AI, augmenting human ingenuity, making people better, making the things that they do better, making the systems that are around them better, and doing that in pragmatic, interesting ways that allows people to move in an agile way and get to results really quickly. So if we look at some of the history, and we heard earlier around some of the Bayesian decision theory history that's been going for a while, if you go back to the sort of eras of Turing and the work that they were doing at the time, and even Feigenbaum and the early research of languages like Prolog and Lisp, that was the first AI spring. But in the sense of that spring, we actually missed summer, autumn, and winter, and actually went straight to the AI frozen era, to the ice age of AI, where nothing happened for many years. Although the research continued. The research continued, and the applications were there, but limited. But the consequence that happened after that is really we're back at the AI spring. And there's really because of two things that have happened. The first one is about the algorithmic enhancement, being able to run very deep neural nets, being able to run these algorithms, but secondarily, having a place to run them. So when you've got the cloud, and we'll sort of see how that's decomposing as well, but algorithms on the cloud are really the sort of catalysts for where we are with AI today in terms of it being the sort of democratization of AI and making it available to everyone. So the way we think about it is really having this cloud platform to be able to run the AI. And the original definition of the edge was your phone or a tablet, but you quickly discover that the edge is actually different sizes. The edge could be a Raspberry Pi. The edge could be a rack of servers. The edge could be an airplane. The edge could be a car. The edge could be a machine tool. So the definition of the edge now becomes fairly broad in terms of what those capabilities are. And so the technical architecture is about how you integrate what's capable of doing in the cloud and how you push that out to the edge for something that we'll call real enough time. So it's not necessarily real time, although it may be, but the algorithmic processing actually happens as close to the events as it can be to reduce the backflow of bandwidth to be able to make decisions as close to the events as possible. And that's what the intelligent edge is about. And whether that edge is a drone, a car, an airplane, or a boat, or a person, that's really what the underlying technology architecture lands up being implemented. So the question I get often from many enterprises is, where should I start? Where should be my first foray into AI? And the flippant answer to that is always start below your current maturity. And so one of the pieces of work that we've done is to develop an AI maturity model that talks about different layers of sophistication and maturity, and you can evaluate where you are today. There's categories in the evaluation. But the worst thing that you can do is take a company or an entity that has a low maturity and actually start to develop massive deep learning, machine learning algorithms, because you will probably fail. So there's an interesting question of what are the steps that you can take to take you from one level of maturity to the other. So one of the things that we've discovered is that there are 4 categories of competencies that we look for. But the most interesting observation about these capabilities is that only one of them is about technical competency. Only one of them is, do you have the data scientists to be able to understand the learning models? The other 3, around strategy, culture, and organization, are about who you are and the way you work. So as a company, if you do not have a basis for making data-driven decisions, going into AI is not going to get you where you want to get to. So there are a whole series of things that you need to do that takes you on that journey. Applications you need to be developing, you need to be running, you need to be operating. There's a whole interesting discussion that I won't get into today about what does it mean to actually be running your own machine learning system. Just think about as the model changes, what does it mean to support a model? Because models change constantly. Models change when they're trained, but as the more you use a model, it changes itself. It learns all the time. So what does it actually mean? And so what we've discovered is that developing AI solutions is a highly iterative, agile process and not a waterfall process because it never ends. Once you've started to build a model, you're in model management and model process optimization forever. So how your organization set up turns out to be one of the key factors of whether you are going to be successful or not. There's a key element that comes out of this, which is the ability of people to deal with probability. We've come from a world of causality, which was there's a direct correlation between the things that I do and the outcome. If somebody asks you a question of what were your sales last year, you can come back and say 932 pounds and 42 pence, an exact number. It's this notion of causality. But the place that we're coming to, and you saw this earlier in the picture that showed you the recognition of objects, those little boxes, and each one of those little boxes had a probability there. And the core issue is then the ability of people, humans, to deal with probability. You'll see an outcome, and the system will recommend there's a 72% probability that this event can happen. And how humans consume that number is fascinating. Because an awful lot of people today will look at it and say, 72 looks like 100, therefore it will happen. But that's not really the case. 72% yes, but there's a 28% probability that it might not. And that's a very real possibility. And so there's some great research that we've been doing based out of New York, which is looking at the ability of humans to deal with uncertainty. This is actually going to be one of the big breakpoints that is actually going to change information workers. The people who deal with the outcome of these algorithms and their ability to respond is their ability to deal with probabilities as opposed to exact numbers. And this is, again, one of the maturity levels that we think about on how we get there. So this notion of open loop and closed loop starts to become interesting. An open loop is an AI system that suggests to you a recommendation with a certain probability. Closed loop is when the system decides to do something itself, where programmed into the model is to recognize the recommendation and then take an action on it. And that action might be very positive, but it might have some other impacts where you're actually driving a car and you hit a lady on a bicycle. So this notion of open loop and closed loop AI is actually, we're in very early days. And autonomous driving is really the key example of closed loop, although we've had autopilots on airplanes for many years that actually react in the same way. But open loop is where we're going to be today for a long time, which is that systems make recommendations, and then it's about the ability of humans to consume that information and react into it. We see this a lot when we talk about digital transformation in enterprises, about actually looking for what we'll call analog hotspots. So if I look through any of your processes today, as you've been digitizing them in one way or another, what we'll discover is a breakdown somewhere in the middle, where there's an analog hotspot. An analog hotspot is you've got this wonderful automated process, and then somewhere along the line, somebody's writing down something on a little piece of paper. It's an analog hotspot. And it turns out that artificial intelligence is one of the key capabilities that allows us to digitize that hotspot. And so this notion of digitization, process change, business optimization is really being powered to a large degree by AI today, so that AI becomes a catalyst for transformation. And these two things are actually wrapped around one another like a double helix. They're wrapped around one another in the sense of you could start with digital transformation of your business and land up with an AI capability. Alternatively, you can actually know what AI does and actually go the other way and say, well, now I can optimize and change my business process. So it's very hard to separate these two. So the digital transformation conversation that we've been having for the last 4 or 5 years has suddenly changed and is really deeply embedded with the competencies and capabilities that AI provides us with. The way we think about this overall framing is really in these 3 buckets. The platform for AI, I'll show you a picture of that in a moment, but then infusing AI, what it means to infuse AI in the products that we ship that you use every day, but also infusing AI into your applications. So when you're using something like SwiftKey, or you're using something like translation in PowerPoint, there's deep AI running behind that that is really enabling you to be better. It's actually augmenting your ingenuity in the things that you do. But how are you thinking about embedding AI into your processes? And that's sort of that dual challenge that we've got, is embedding AI into products from things like load balancing, but also embedding it to what you do to make your sellers better, to make them more predictable. And the final piece are then finished AI solutions that actually provide intelligent sales support, intelligent legal support, intelligent IR support, for example, in how we actually get there. And so the way we think about a platform is the underlying technology of the platform, the set of AI services that sit on top, but just as important is the set of tools and runtimes that runs with that, because developing an AI solution has the same sort of methods behind it as developing any other solution. You need to have tools that give you testability, repeatability of the function, sharing and collaborating around its development. On the sort of services side, there are really two different modes of operation. One of them is when you call cognitive services like text recognition, voice recognition, pattern recognition. And that's a simple programming model. You just have to be a programmer who can call a set of services. You don't really have to understand the way the AI works. Translate this text, tell me the sentiment in it. You call an API, you get back an answer. So that's a very classical application developer paradigm. But there's a very different one, which is around developing machine learning, which is really a new set of skills and disciplines about how to develop real AI applications and how we do that. So one of the questions I get often is, what are the core assets of AI? How should we think about investing AI as companies who consume and use AI? And there really are three core assets when you think about AI from a balance sheet perspective. The first one is the neural net engines. You shouldn't really worry about that. There's lots of work going on. We're doing work. The other vendors are doing work. There's open source work. I'd recommend you don't spend a whole lot of time trying to build your own neural networks. But the two others are really the places that are significantly important. The first one is in the models. Now, you will develop models. You'll probably buy some models and then adapt them to your business. But the AI machine learning model is what makes your business different to somebody else's. It's your differentiation is in your model, so they'll be very proprietary and very valuable. Now, you might buy a starting point, but how you customize that to your business will actually be your unique differentiation. But an empty model without data is like a database without data. It doesn't do anything. What makes a model unique is the data that you train it on. And most conversations that I have with many large organizations, they say, well, we've got all the data that we need. We don't need any more. And you couldn't be more wrong, because there's so much more data that's out there that you can actually share on. But one of the interesting things about the training data is inherently biased. All of us, in one way or another, have bias. And given that models and data are performed by humans, models are inherently biased. And I'll give you a silly, simple example. Let's say you were to do a machine learning model to look at the depreciation of brake pads on a car. But the data that I used to train it is actually from a Jaguar F-Type. Now, if I take that same model and test it against an E-Type, that's probably not going to work. But if I test it against a VW Bug, a Daimler, or a Toyota, it's going to be different again. And so inherently, my data is biased. My data is biased to the way it was trained. Not only the way it's trained, but every time you use it, like any machine learning model, it learns more. And so the notion of your data and the value of your data, but it has to be disparate and unbiased, which means that as you model the real world, as you look at the real world around you, and because of IoT, suddenly you can measure things that were not measured before. You can bring in all this information. So it's not only the data of your systems of record, it's the data of the world around you. And as you bring that in, you quickly discover you don't own all that data. And so one of the consequences of this is a data marketplace, an ecosystem of data, where you will buy and trade data in some form or another with your trading partners or even people in a free market. The business model that underlies it depends on your contractual relationship. The business model might be a transaction, give me once, give it to me every week, give it to me when it changes, or maybe I'll give you some of my data and you give me some of your data. The notion of the tradability of information is actually huge, but the outcome is that your models become better because of the data that they're bringing in, instead of being biased by the data and the information that you have. And so one of the things that's happening in the world is that we've spent the last 25 years focusing on the data estate. Started off with ERP systems and enterprise relational data models. But the world that we're going to is the layer that sits above that, which is actually the world of knowledge. So if you look at this sort of architecture slide, it has data sources on the one side, which are both real-time and non-real-time, public sources and private sources. The first step will be ingestion, which is actually bringing that data in, mapping it, and storing it. But then producing this layer of knowledge around it is you take various AI tools and start to build knowledge of your systems and your processes and your customers and your products and your services and maybe even your competitors. And then once you've got an answer, projecting it out to the people who want that information, which could be back to the edge, but it could be to your customers, it could be to your employees. The key message from this one is actually the time that we've spent working on the data model now actually needs to change, and we need to invest on the knowledge, the underlying knowledge about your people, your products, your services, and your business. That's going to be the next step of creativity, the next step of differentiation from many enterprises around the world as they work through this. And so if we look at the kinds of applications that we see being built, we see a lot of the sort of conversational AI of bots, but we also see some very sophisticated applications being built in call centers that have dynamic dialogue builders, dynamic intent builders, that really start to change the way you start to communicate with your customers in very different ways. We then sort of look at object and people recognition. I'll show you some examples of that. But one of the most interesting fields is AI-assisted professionals, which is about assisting sellers in some form or another, assisting marketers, engineers, HR professionals, your employees, and how can we use AI to actually make their lives simpler? And so there's lots of examples that we can see across marketing and sales, but even talent management inside of your companies and how we think about people, hiring the right people. One of the interesting applications that people jump to with AI is actually being able to scan resumes coming in. But how do you find the ideal candidate for your business? Turns out there's no such thing as an ideal candidate because diversity of teams is incredibly important. So in a model that was actually going to look at resumes, you actually want to have the real model, then you want to have the anti-model that's going to make a recommendation to give you the diverse set of candidates inside of your pool. So a lot of these have this sort of underlying intensity of understanding the models and the way the models work. This is a system that we run internally. It's called the Daily Recommender. It actually runs with Microsoft Inside Sales, so the folks who's on the phones talking generally to smaller businesses. And what this does is every morning when the seller comes in and signs into their system, they get this prioritized list of work based on an AI scan of what's happened over the previous period. It pulls in about 1,000 data points that looks at you as a customer, customers who look like you, their behavior, and the events around it. And the ability to say, well, somebody downloaded a white paper over the weekend. I want to call them on Monday morning and say, you know what? We see you downloaded this paper, but companies that look like you in your industry have actually used Office 365 in this way. So it's fundamentally changing the behavior of a seller. And because in each case it's scanning 1,000 data points every day, there is no human who can actually consume 1,000 data points. But this is a recommendation. This is what I call an open loop system. It's actually a prioritized list of balanced recommendations that as a phone operator, I can now pick up and use. So we use this inside of our internal call centers today for inside sales. Let me give you some simple examples. And one of the messages I'd love to get across with these examples is AI is real and AI is agile, and you can build real solutions that add value to you today. First example, bridge maintenance. I know more about bridge maintenance than I ever thought before. So if I have a large bridge, and I'm the engineer responsible for maintenance on the bridge, how do I actually find out where there are defects in the concrete? So the way that would have happened is the maintenance company would shut down a lane of the bridge. The engineer would walk that with a camera. He would take various pictures, label them onto a plan, a map of the bridge, and go back to his office and look at the pictures and correlate them to location, and then sort of make a work plan of how to actually repair the bridge. The great thing is that drones, in the sense of IoT, changed that, because instead of walking the bridge, he'll just fly a drone down the bridge and then sit at his desk and analyze the video footage. That's still what I would call an analog hotspot, because you've still got somebody observing analog measurements to make judgment. See, here's what happens. It turns out there are 3 kinds of defects on a bridge. I said I knew more about bridge maintenance. The first one is about algae and bacteria on the bridge. The second one is about cracks, and the third one is rust. So here's what we did. We took that drone footage, and from that drone footage, we actually took 87 frames from the drone, 87 frames, and carved up each one of those frames, and then an engineer labeled each one of those pictures. You can see the little squares here. Labeled each one of those and said, this is a crack, this is algae, this is not a crack. That ultimately led to about 1,100 labels. And that's what was used to train the system, first time through. And the consequence of that is a system that looks like this. First picture I get is a satellite overview of the bridge with hotspots. I can then drill down into the area where I think I need work. I can actually see a summation of all of the pictures in that case, and then the final pictures I can drill down into crack by crack, and I can locate that on the bridge. Now again, this is an open loop system. It's recommending that this looks like a crack with a certain percentage. And as the engineer, I can now make a judgment. It is a crack, it's not a crack. And every time the system has recommended something that is and that the person says is not, we learn. And you'll end up retraining the model in real time. And so what we've done is taken a very manual process into a semi-automated process with the drone, but now we've actually got it where the engineer can do this from the desk. And so the question is, how long did this take? Grand total, 4 weeks to build this. Not perfect, but actually much better than walking the bridge on your own. And so this notion of iterative build starts to become very pertinent to the way AI systems can work and actually generate value, and generate value very quickly. Here's another example, spatial occupation. If you go into many stores, you go to a Starbucks or a bank or a coffee shop, Costa or somebody like that, and you ask them, when was the store busy? The only data that they've got about the store being busy is the point of sale terminal, which is they know that I came into the store, I bought a cup of coffee, and I sat down for 4 hours. Except they don't know I sat down for 4 hours. They know that I bought a cup of coffee. And so how do we actually get that data? Well, it's very easy to take the security camera feed, run that through a recognition system, and I'm not going to, there's no privacy issue because I'm not looking at faces. I'm actually looking at where are people. And now I can use an animated view across the day of the heat map of people in the store. Now the store manager can start to make some interesting conclusions. Do I have the right table set up? Do I need more people at a certain time of day? Can actually start to make data-driven decisions about the store. But prior to that, the only knowledge of occupancy of the store was a little piece of paper where the manager wrote down, at 3 o'clock it seemed busy. But suddenly, I'm using AI to actually get real measurements. This one took 5 weeks to actually develop. I'll give you another case study, which is actually the Microsoft Treasury. One of the interesting problems with the Treasury is actually understanding accounts receivable and predicting accounts receivable. And if any of you end up dealing with sellers, when the seller gives you their forecasts, sometimes they're hard to believe because sellers don't necessarily expose all the information all the time to their managers. And so we built this system to actually look at and be predictive of accounts receivable. Because as a global company operating in over 100 countries, receivables and payables in every country is a pretty important measure for us. And so here's what we found. We actually found that over 6 quarters, the model was 6% better than people. 6% better. Now, if you actually look at the receivables that Microsoft has around the world, 6% is a big number. And if we can actually use that 6% to start to change the way we think about currencies and currency spending, now it actually starts to get interesting. You see a similar view of bots when we develop bots. And what's interesting about bots is one of the things we find out quickly, the chit-chat part of a bot, real easy. The important part about a bot is the personality of the bot, because the bot represents your brand. And as soon as you start to mention a bot externally, now it actually is a representation of your company. The behavior, the language that that bot uses is the way you're communicating with your customers. And so we spend a tremendous amount of time thinking about the language of the bot and how the bot behaves under varying circumstances. Bots also have names. Sometimes they're abstract images. How you pick the way the bot looks starts to be very indicative of the behavior you're going to expect for your consumer. So the easy part of the bot is what's the balance in my account. The hard part of a bot is actually having the customer come away with a great experience. So what is the emotion you want your customer to come away with when they're actually dealing with the bots? But there's another part of the bot that's actually super important, which is the telemetry of the business transaction. In this case, this is actually from a real bot. This is actually a measure of the sentiment in the bot. It's a measure of the conversation with the bot and how we actually talk to them, which is an additional set of data. So let me close on this topic of ethics. The ethics of AI is something that we're passionate about, believe on it. In fact, if you want to see what we've said, there's a wonderful book that we've published. You can download it from aka.ms WAC, Future Computed, that talks about a principled approach. And in that principled approach, we've actually defined as a global company how we think about ethics around the world, and ethical values by country, by organization, and by the things that we do. So we've actually labeled out these various principles of fairness, and we just believe that privacy, for example, folds underneath this. But one of the things that will gate the success of AI, much as we did with the cloud, where what made the cloud viable was the trusted cloud, trusted AI is going to become that same key for all of us in one way or another. So how we deal with it and the consequences of it are very interesting, because one of the things that happens with AI is consequential services. I apply for a mortgage, there's a system that says yes and a system that says no. That's denial of a service. How are you deciding who should or shouldn't get the mortgage? And is your data biased? So there's some great work that we're doing in research to try and understand ethical models and try and understand bias in models. But this is where humans come in. Humans play an incredibly important role in the understanding of ethics and the behavior. There's another part which is about harm, and most people go to physical harm, but what's just as important is emotional harm. Emotional harm in dealing with a bot, and what is the reactions that people can have in dealing with AI in different ways. A great little video that we'll show you here that actually talks about AI at the edge.
People never even imagined that they would be able to have it before. We've got this great ruggedized 1-ton Suburban. We can take this car in a disconnected environment. There's a lot of different data collection devices that are within the vehicle. An in-car camera, 360 by 240 degree spherical camera. We're able to deploy drones from the vehicle. But when you really talk about power, the back is a little black case with the rugged Azure stack and AI that we're able to bring to the edge. The data is amazing, but it's the AI and the cognitive services that turn it into something that we can really use in the real world. We create our own data processing in any environment that this car can get us into. In disaster relief, we have the ability to take in and start analyzing the infrastructure, bridges, roads, and we can find the most effective routes to be able to get aid into people. We can help figure out routes to get the people out of harm's way. From an enterprise standpoint, increasing inefficiencies will save companies millions and millions of dollars. Imagine power lines. We can send a single guy in a drone and a vehicle like this. He's taking imagery of the power lines. We can run the analytics based upon the models that are already built, and now we see that this part can fail or everything's working fine. Being able to take the power of Azure Stack and AI to the edge, to those people that are disconnected all over the world, and bring them the ability to do things that we've never even been able to dream of before, and now we can do that.
So the way to think about AI and AI for good is we can do some amazing things with AI. We can make society better, we can make people better, we can make it that way if you run it from the cloud or if you run it at the edge, as you see in this example. Where you run it is not going to be that important, but how you run it and the things that you accomplish with it will be. So the same way as we said that every company would be a software company, you probably heard this 5 years ago, every company is going to be an AI company, whether you like it or not. Every company in one form or another will be an AI company. But there's some interesting corollaries out of that. Not having an AI strategy is actually no plan. You have to have an AI strategy of some kind. But what I see some people doing is they're saying, our strategy is no AI. And that's not a strategy either. Every company in one form or another has to have a sense of how you're going to deal with AI, a sense of your maturity. But as we've published that book, we're expecting every organization, public sector, private sector, governments, companies, and organizations to actually write your AI manifesto. Because in some way or another, all of you are dealing with AI, you're dealing with your customers, your partners, and citizens around the world, and actually taking a stand about what you believe about the privacy of AI, the value of AI, and the bias of AI is really what's going to differentiate companies as we start to develop these amazing solutions that are going to really focus on augmenting human ingenuity. Thank you.